In this video, we will talk about again the concept of pass by value, but we will see how it impacts the objects. In the last video, we saw the behavior from primitive variables perspective. We saw that if we initialized an integer value in main method with 10, for example, then we called a method pass this value to that method and doubled the value in that method, but it didn't change the actual value because in Java everything is passed by value. So when we we pass the value of I, we actually passed the copy of I, and whatever we did in the method m was actually on the copy of that value, so the actual value remained the same. But what happens if the variable is actually a reference variable? If we are dealing with objects, how does that how does this concept impact a reference variable? So in this example, we have a main method and we are creating an employee object with reference variable e, and we are setting the id property to 10. So this employee object has a single property, integer property id, and the value is 10. Then we are printing the id on the console. After that, we are calling a method m, and we are passing the same reference variable e. And then after m completes its execution and control goes back to the main method, we are printing the id again on the console. In method m, which accepts the declaration says that it accepts an input argument which is an object of type employee, and then in the method body it is changing the id of that employee object to 101. Now let's analyze the program, and then we'll see what is the actual output. So when m starts its execution, it will, because we are creating a new object and objects always are created on the heap, so on the heap there is a new object created, employee object. Let's name it employee object, and its id is 10. So this is the new object and its id is 10. E is the reference variable which is pointing to this object. Now we know that reference variables do not hold the actual object, but their value is basically a bit pattern, and that value represents a link to the actual object. So let's say the bit pattern of reference variable e is something like xyz, and this xyz value is pointing to the actual object on the heap with value 10. Now when this line executes, it basically prints the id of that employee object. So on the console we see the value 10. So we see the value 10 on the console. Now method m starts its execution. In m there is an input argument of type employee. Now what happens? We know that Java creates a copy and passes the value. So Java will create a copy and pass that value to the method m, and m will store that copied value in the reference variable of name emp of type employee. So this is method main, and now we are in method m. So employee has a copy of those bits. So let's say this is abc, but even though abc is the copy of xyz, because it's a copy, so we know that these two bit patterns have the same value. So that's why emp in method m is also pointing to the same object. It is basically a reference variable. So in the method m, emp is pointing to the same object, and on the next line, what method m is doing via this reference variable emp, it is accessing the id attribute and changing the value to 101. So what it is doing is basically when this line executes, method m via emp variable will change the value to 101, and then the method completes its execution, so the control goes back to the main. Now in the main method, on the last line, we are accessing the object referenced by reference variable e. So we go to this object because e is pointing to this object, and now we are getting the id attribute and printing it on the console, which is 101. So we see the output 101. In this case, we saw that if we passed the same object to the method and if we are changing something on that reference variable, it is actually impacting the actual object in method main. That's because reference variables are pointing to the same object. Reference variables are handles. Even if we create the copy of the bit pattern, this is basically a copy of an address. They both have the same address, they both are pointing to the same object, and that's why in method, if we change something in that object via the reference variable, it will actually impact any other method or any other reference variable that is pointing to the same object. But because of the copy process, Java is still pass by value. So that is the concept of pass by value, and we covered both the cases, primitive in the last lecture and in this one from object perspective. Thank you.